Welcome, this is Anna, and we're going to be doing part 3 now of the autonomic nervous system, looking at neurotransmitters. All right, when we're talking about the autonomic nervous system, we need to talk about those neurotransmitters, which I've already mentioned before, but let's talk about them in a little bit more detail. The first thing we're going to do is mentally divide them up into cholinergic versus adrenergic. So I want you to remember cholinergic. You're going to be associating that with acetylcholine, Tylch. All right, so that refers to that, not that part, not the acetyl group, to that part, okay? And then adrenergic is referring to adrenaline, which is epinephrine, okay? Epinephrine and norepinephrine, okay? And from now on, I want you to not use the word adrenaline. I want you to just use the words epinephrine and norepinephrine, but that's how you remember what adrenergic means, is to think of adrenaline. Okay. Now, when I'm thinking about these neurotransmitters, I'm thinking about what do they work with? How do they work with? What do they do? So I know that my acetylcholine is going to be working with those somatic motor neurons that go to my skeletal muscle, okay? But I also know that it is going to work with all autonomic, preganglionic axons, okay? And it's going to work with all parasympathetic, postganglionic axons, okay? So where do we use these adrenergic stuff? Well, that's going to be over here with the sympathetic, okay, postganglionic axon plus adrenal medulla, okay? So I need to keep those things straight in my mind as I'm trying to remember them, okay? Now, I can also remember that we can use different names for different things, okay? So sometimes when we're talking about the axons, we will talk about cholinergic fibers. So these preganglionic axons that secrete acetylcholine are considered cholinergic fibers. The sympathetic postganglionic axons that can secrete epinephrine and norepinephrine can be called adrenergic fibers. All right, so the fiber is referring to the axon. Okay, let's focus in a little bit on the cholinergic. So we're going to make that center stage here for a little bit. So again, we know that it responds to acetylcholine. Okay, the thing is, we can then further divide this up into two categories. Okay, I have the muscarinic and I have nicotinic. Okay, and they do different things. So we've got two types of receptors. Some receptors respond, two types of receptors that are cholinergic. Some we call muscarinic and some we call nicotinic, okay? And it's all about what does it easily bind to. So the nicotinic is similar to the compound in nicotine, okay? And it's going to be, so let's write that. It's not nicotine, but it's similar in shape to the nicotine, okay? The other thing to remember is that it's always excitatory, okay? And these nicotinic receptors, all right, you're going to find them in all autonomic ganglia, okay, the adrenal medulla, and then also skeletal muscle, okay, because it's excitatory. And if acetylcholine is exciting, all right, this is a good type of receptor to have, okay. Now, muscarinic, this one is named after the fact that it's similar in shape to a mushroom toxin, okay. So that's where we get the word muscarinic from, okay. Now, it's not found everywhere. It's more limited. So some sympathetic target organs have muscarinic receptors, okay? So an example that you know of would be your eccrine gland that you use for thermoregulation, okay? So not all organs have the muscarinic, only some of them, okay? Now the muscarinic is different from the nicotinic because it can excite or it can inhibit, okay? So an example of something it would excite would be the vasodilation of certain blood vessels, okay? But it is going to inhibit cardiac muscle. All right, so those are some examples. Okay, now let's kind of move back over here to our adrenergic and let's change color because why not? Okay, so we've got two major classes of adrenergic receptors. You have the alpha and you have the beta, okay? Alpha tends to be excitatory, okay? Beta tends to be inhibitory, okay? Except at the heart, okay? Where the heart, it excites, okay? So some examples, all right? The beta will do vasodilation. Let me rewrite that neater. Vasodilation of blood vessels, but only in the heart and lungs, okay? Because over here, the alpha is doing vasoconstriction elsewhere, okay? Now, this is important to think about it. If you are running from a bear, you don't want to be digesting lunch, but you do want your heart and lungs to be working really well. So you're going to do vasoconstriction in places like your gut and vasodilation in places like the heart and lungs when you're using that adrenaline, okay? So some other things it's going to do is constrict GI sphincters, okay? Because again, you're not digesting lunch when you're running from that bear, okay? It's going to dilate pupils of the eye. So you can see some places it inhibits, some places it excites, okay? So what you have is an important dance between excitation and inhibition depending on whether you are doing daily normal functions versus whether you are engaging your fight, flight, or freeze response, okay? And you can see it's not simplistic to say that it's either going to be cholinergic or adrenergic for things like vasodilation, because you can see you will use it in different places in different ways. All right, so think about that, and I'm going to go ahead and stop this recording, and you can move on to the next one.